Hope so you are fine. Welcome to the world of chemistry. And this is your digital classes. समय 10 से 12 वाला हर घर बने पाठशाला. And this is your chemistry period. So as we know, we are doing our unit 4. Name of the unit is chemical bonding and molecular structure. Okay. So today's topic is valence bond theory. As dear students, yesterday we have finished our valence shell electron pair repulsion theory, in which we came to know this theory is very helpful, very useful to predict the shape of molecule with the help of bond pair and lone pair. Today we are going to do our new theory. Before that, let's recapitulate and let's start with the positive mindset. Dear student, you can see the picture very clearly. It is representing the sad reality of today's, in which one boy is sitting in the standing in the center with the football, and rest all the boys, or you can say all the kids, they are busy in their social networking, online games, on mobile, I can say. So this picture is representing, this is the situation at present. You must play, you must go outside your home, you must do exercise, you must play that physical game. Okay, although nowadays there is due to this COVID-19 we need to keep take care of the social distancing. We don't need to go out of your game, but it doesn't mean that you will sit inside in one room with your mobile and play only online games. Okay, everything is important, but it should be under the limitation. So this message is for all those students, those who are sitting continuously 5 to 10 hours whole night on online games, and because of that their mental stress, they are going to become irritated, they are going to become very much angry, they are going to become very much I can say out of control. Their body is not out of control and their mind is not out of control. So it's my request, just cut your little bit time from online games or online social networking. Just go play with your neighborhood friends and just enjoy. Okay, so although this is very you are feeling today, I think what happened to sir, and sir is talking about go and play, not about study. Yes, everything is important, as I said. So you have to do study when your timetable is of study. You have to play when your timetable is of play. You have to connect with your friends through social media. If you have, then you must have to do that also. Okay, so let's start the recapitulate of this chapter. The chapter name is chemical bonding, and we are doing the different types of chemical bonding. Octet rules we did, its limitation, then covalent bond and its characteristics, bond parameter and polarity we did, prediction of geometry with help of bond pair and lone pair we did, valence shell electron pairs theory, which is called, today we will do valence bond theory. But before that, let's see this slide very carefully. Okay, the slide is showing that when the time was there, when teachers are teaching, I can say here, teacher is teaching with the help of traditional way, like blackboard, chalk, green board, chalk. Then somewhere this is your reaction. Student's reaction is like this when he is teaching with the help of only green board. And somewhere when we are asking you to read books, your reaction is like this way. If now we will ask you now, okay, go through the internet, then your reaction would be like this. Now if we will ask, okay, do group discussion, gossip each other, but discuss only your study content, yes, study material, yes, study issues, or I can say the topics, your reaction is like this. Okay, and now all these things, you can see all these things, now we are bringing in one small notebook, or you can say in your notes. Okay, then you feel like this. Okay, so dear students, my motive is to just relate these slides to you. Reason, today we all are at home, we only depending upon our network or mobile, or I can say internet. So you must apply all these things so that in the end your exam or your answer sheet should be filled with the quality answers. Okay, so next is, if I will talk about concept map of this chapter, chemistry is study of matter, we did, in which element and mixtures are two type of matter. Then we discussed the matter can convert into compound, in which one or more than one molecules are there. These compound have some bonds, that is called chemical bond. I am relating a whole whatever we did. This is unit 1, then unit 2, now unit 3 we are talking about. Okay, which have bond: ionic bond, metallic bond, covalent bond, polar covalent bond. 4 type of bond, which form later on crystal, that you will study in 12th class. This crystal you will study in 12th class. Then what is the use of these compound? The use of compound is by molecular orbital theory, that we will study in the last topic of this chapter. Today we will study valence bond theory. What is the use of valence bond theory? It helps us to tell us about polyatomic molecule, those molecules which have many more than one elements, and through hybridization process. So hybridization is important. This helps us to know about the electron wave function orbital in future, and the shapes of molecule we studied already about Whisper theory. So this flow chart will help you to understand from where we start and now where we reach. Okay, so let's start. The types of chemical bonding: there are ionic bond, covalent bond, metallic bond, and polar bond. So ionic bond is what? It is normally between a metal and non-metal. Okay, it is very important. Whatever slides I'm going to tell you, this is very important for chemistry, so pay attention and watch the video carefully. Just pause, study again, then move forward. Okay, ionic bond is the normally it is between metal and non-metal. You can see sodium is metal and chlorine non-metal. Sodium possesses positive charge, chlorine possesses negative charge, so that's why it is becoming ionic bond. Now these positive and negative charges, they exchange electron. Like positive charge sodium will donate electron to chlorine, negative charge, and negative charge chlorine is attracting the electron, and they will remain together with the help of electrostatic force. The name of force is electrostatic force. And later on, these kind of molecule, those molecule which is bounded with ionic bond, these molecule are forming crystal. Later on it form crystal. Okay, so जो आपका टेबल नमक है, the salt you have, that is crystal, simple, and formed with ionic bond. Now move for the second, covalent bond. Covalent bond are between two non-metal. Now this is between one metal, one non-metal. So covalent bond are between two non-metal by sharing of valency. Here valency is playing very important role. Already we have studied everything. So here just to complete octet, just to make 8 electron in outermost shell, the electrons, the elements, they will donate or share electrons. Suppose carbon share 1 electron with hydrogen. Similar way, hydrogen will share 1 electron with carbon. So in this way, they can form 8 electron. That is called covalent bond. And most successful type of molecule are these that we'll study. Third is polar covalent bond. Here, two non-metals share electron unevenly because the electronegativistic difference. So how? Electrons are close to one atom than the other. Suppose I am taking example of H and oxygen. You know hydrogen is very small and electron is only one, whereas oxygen is very large and electron cloud is more. So you can see the polarity of hydrogen is toward oxygen side. That's why on oxygen there is a negative charge and hydrogen there is positive charge. This result on partially negative and positive charge, that is called polarity. Polarity means direction. So this direction of electron is toward this side. Okay. Next is metallic bond. As name represent metallic, so metal atoms share all their valence electron which freely move between all atoms which form a network, that is called metallic bond. जैसे copper wire है, tin sheet है, there is a iron sheet. So these all sheets are made up of metallic bond, and therefore all metal can conduct electricity and look shiny. There are basically 4 type of bond we studied. first bond we studied ionic bond. If we will take happens between, so it is happened between metal and non-metal, covalent non-metal, polar non-metal, metallic metal. If electrons we will talk, so then ionic transfer from one atom to another and create ions. Whereas here sharing of ion, here sharing of unevenly mean not equal between two atoms and shared in large pool with all atom. If we will talk about characteristics, it is highly melting point, brittle, and even dissolved in water and conduct electricity when aqueous. Whereas covalent bond, low melting point, do not often dissolve in water, do not conduct when aqueous. It is medium melting point, sometimes dissolve in water, not conduct electricity when aqueous. It is very soft, conductor of heat and electricity, do not dissolve in water. Okay, so this is very important page. So you just pause this and note down these notes in your notebook. Next is bond polarity we studied in this chapter. So let's understand bond polarity with the different type of slides. So bond polarity is what? It is a polar bond, uneven sharing of electron due to difference in electron activity, as already we studied. So that is called the pull. Pull an atom has for electron. Mean if one atom is pulling other atom by taking electron due to high electron activity than the other, then it is called polarity. The oxygen is more electron active than carbon, and the oxygen will pull on the electron harder. The electron will move closer to the oxygen. Yes, suppose oxygen is more electron than this oxygen is more electronegative than carbon. This oxygen is more electron than carbon. So you know very well carbon have basically 4 electron. So we are making carbon dot structure like this way, 1 2 3 4. But this side oxygen is there. The oxygen will pull both the electron, and oxygen require 2 electron. So obviously oxygen will pull 2 electron one side and 2 electron other side. That's why the shape of what carbon dioxide is like this way, linear. 2 electron this side, 2 electron this side. This 2 electron is shared taken by this side oxygen, 2 electrons of carbon shared by this side oxygen. So this will leave the carbon with a partial positive charge. Yes, that's why carbon have positive charge, because it leaving its 2 electron, losing 2 electron, and oxygen have negative charge, partial negative charge. Okay, so this is going to be explained with the help of this picture. So you can see here there is one animal which is stronger and there is one animal which is weaker. Suppose take hydrogen is animal which have weaker and oxygen is that animal which have stronger. This is oxygen, this hydrogen is written very carefully. Okay, so now oxygen is tying that hydrogen strongly with the help of this thread and pulling the hydrogen toward oxygen side. So we can share, but I want it closer to me. Oxygen is saying we can share electron, but I want you should be closer to me. And how he will come closer to you? And he don't want to go closer, hydrogen, but it is bringing closer due to its higher electronegativity. The basic chemistry is higher electronegativity. Hope so you understood. So because of this polarity, now dipole moment is creating. You can see this is that arrow of polarity. So which side negative charge is there? That side it is pulling, and other side it will carry positive, and negative side it is carrying. So you can say head of the arrow is toward negative side and tail of the arrow is toward positive side. So this you need to take care. The magnitude of the polarity, magnitude means direction of the polarity for a bond is called bond dipole moment, which is shown with mu, this mu. Okay, and the more electronegative atom pull shared electron closer partially negatively charged, less electronegative atom shared electron further from partial positive charge. This you understood. So suppose we have 3 example here. HF, H have less electronegative than F, so F will pull the H, chlorine will pull more, bromine will pull more. Okay, so higher, so it means that this is the dipole moment. Dipole moment is written by dy or dy. This is the SI unit of dipole moment. So dipole moment of HF is 1.91, HCl is 1.08, and HBr is 0.80. It means that down the group dipole moment is decreasing. Next is what causes dipole moment? It's polar molecule. Electron are more equal sharing in a bond, which can lead in dipole moment of the whole molecule. That's why polar molecule is responsible for dipole moment. The polarity can affect several properties of molecule. More polar compound generally have higher boiling point and greater attraction between molecule. The positive area of these molecules are attracted by the negative area. So we can understand with the help of these two diagram here. One is having this kind of, this is called chair. This is called chair. You can see here. Green molecule, green element are alternate with opposite to each other. Opposite mean one direction is this side, other dipole is this side. Okay. Whereas in cis, this is trans, this is cis. Cis is boat type. Boat type. You can say this is boat type and this is chair type. You can see, no, this is chair type and this is boat type. Okay. So chair and boat, cis, trans and cis. So cis have why? Cis have almost less, more boiling point, because the direction of dipole in cis is same, towards same side, like here also towards same side. Whereas in boat, in trans, it is opposite. It is opposite. Okay. So that's why its boiling point is difference. So just check your progress now, what you understood. Which of these molecules have greatest dipole moment? So you just have to note down, write it and send it to me. Okay. Now which type of bond is there? So you can see compound contain metal non-metal, which is called ionic. This is conclusion, that revision I am doing. Non-metal only, it causes two type, electronegative difference and electronegativity. That is covalent bond, polar covalent bond. Two type of bond is from non-metal non-metal. Metal non-metal is bond ionic and metal only is metallic bonding. So this is the revision of first part. Now dear students, if valence bond theory we are doing, so before that it was very important to understand these polarity, dipole moment, or I can say the type of chemical bonding. So now theories, some of the theories are there with the help of which can explain the molarity or molecularity, I can say the structure, shape. So first is valential electron pair repulsion theory, that was depending upon bond pair and lone pair, number of bond pair and lone pair. Valence bond theory, that is depending upon hybridization and overlapping, I can say hybridization or overlapping. Okay, overlapping. And third type of theory we will study, that will talk tomorrow, that is molecular orbital theory, electron delocalization. So let's start covalent bond quickly. I'm going to just read and understanding we will do tomorrow. Lewis structure and Westphal theory do not explain why a bond form. How do we account the shape in terms of quantum mechanism? So what are the orbital that are involved in bonding? We use valence bond theory. If we will talk about orbital theory, it means that we are talking about valence bond theory. Okay, this is the mean. So a covalent bond form when an orbital of two atoms overlap and the overlapping region which in between the nuclei is occupied in the pair of electron. There are two electrons in opposite spin in the orbital overlapping. So there is basically example, atom approach to each other. Two atom approach to each other, they will come closer, as you know that H plus H become H2. Now how these H2 become? This is, you know, well, this is single H, this is single H. Now how these two H2 is? So somewhere H2 is overlapping like this way. I am going to explain here the same. This is one H, one electron of H. This is second H, one electron of H. When they will come closer, so automatically the electron of 2H will become anti-clock and clock. Okay, the electron direction is, this electron is going to be become opposite, because always opposite spin will attract each other. So that's why the H1 become H2. Hope so you understood. Okay, and once 1s will plus, it become 1s2. Two electrons are there. So this is the basic chemistry, how two elements react. Once again, when two atoms are coming closer to each other, suppose this is H1, it is coming closer to second H1. When it will come closer to you, closer to each other, then the second H1, one of the electron of both the hydrogen will become anti-clock. Suppose now this electron become anti-clock and this electron remain clock direction. So this clock and anti-clock will come closer, and because of that you can see a small overlapping is there. Small overlapping. Otherwise you can draw this like this way, but we are not drawing. We are making the diagram like this way. So it means that this is small overlapping here. Okay, Hope so you understood. So this overlapping is called covalent bonding overlapping, that is valence bond theory. So see here example of HF. Hydrogen is spherical in shape, F is P shape, 2P, Px, okay, or you can say F2, 2P, 2P. So it is, you know very well, in second chapter we studied S shape is spherical, P shape is dumbbell, D shape is double dumbbell. We studied or not? Yes. So when S will react with P, so it will overlap like this one. When P will react with P, it will overlap like this way. This is making sigma bond. Once again, note down, it is making sigma bond because there is single overlapping, that is called sigma bond. Sigma bond means single bond. Sigma bond means single bond. Between hydrogen hydrogen there is single bond. Between HF there is single bond. Between FF there is single bond. Okay, but when oxygen oxygen we will do, then it is double bond. When oxygen oxygen we will do, double bond. So how the oxygen oxygen is double bond and hydrogen hydrogen single bond, today we are going to know that answer also. So next is, as two nuclei approach to each other, atomic orbital overlap, that we come to know. As the moment overlap increasing, the energy of interaction decreasing. At some distance, the minimum energy is reached. The minimum energy corresponds to the bonding distance. Then it is called bond length. That's why it is bonding. What is bond length? Bond length is the distance between two nuclei, as you studied. So minimum energy corresponds to the bonding distance is called bond length. As the two atoms get closer, their nuclei begin to repel and energy increases. At the bonding distance and attractive force between nuclei and electron just balance, and repulsive force, that is called nucleus and electron repulsing. Okay, my question is there, we studied already that mean two atom come closer. Let me take other color. Okay, this we studied, mean two atom come closer to each other like hydrogen and overlap, form a bond. Why not then these overlapping is continue, and why not this overlapping is increased, like from here then later on this will overlap totally with each other? Why two atoms are not completely overlapped? Reason, after a interval, you can say after a fixed energy bonding distance, or after at a bonding distance, fixed bonding distance, the attractive force between nuclei and electron, it will just balance, and one repulsive force will create by their balancing, that is nucleus and electron repulsing. When nuclear and electron repulsion force is there, then overlapping stop there. That's why overlapping just form bond, not total. Okay, this type of, when two type of atom will overlap each other, when two type of orbital will overlapping, that situation is called hybrid. Hybrid is now mixed. So atomic orbital can mix, or atomic orbital mix, like first one hydrogen, that is pure hydrogen, now one more hydrogen, that is also pure, but both pure hydrogen mix, they become hybrid means mix variety. Okay, so atomic orbital can mix or hybridize in order to adopt an appropriate geometry. When they will get hybridized, when any molecule is getting hybridized, then they form some appropriate geometry. Hybridization is determined by the electron domain geometry. For example, we have so many type of hybridization, I am telling you, then in the next video we will study in detail. sp, sp2, sp3, dsp2, dsp3, okay? These are the hybridization. So atomic orbital can mix and hybridize, this we have studied. Suppose for example in beryllium has configuration 1s2, 2s2. There is no unpaired electron available for the bonding, so we conclude that the atomic orbital are not adequate to describe orbital. So we know that beryllium fluoride, BeF2, somewhere will make the 180 degree according to valence shell electron pair theory. We studied that BeF have 180 degree, that we studied in valence shell electron pair. We also know that one electron from Be shared with each one of the unpaired electron of F, but that was how, that we will study. We assume the beryllium orbital in BeF bound is 180. We could promote an electron from 2s orbital to Be to 2p. Now we can solve the problem by allowing 2s to 2p. We do hybridize. This is beryllium, this is fluoride. Okay, when beryllium will overlap with fluorine by giving one electron, then they will combine, and once they will combine, they will form like this kind of structure. This is called sp hybrid. So now beryllium or fluorine or one more fluorine will be there. The same way it will combine and it form beryllium fluoride. That kind of hybridization called sp orbital. Okay, so similar way we have sp2, sp3. So today I think this lecture is going to be little bit long, so I'm going to end it here. Tomorrow I will tell you about the structure of beryllium chloride with the help of hybridization. sp2, ठीक है. Then these are sp में कैसे होगा, sp2 how, sp3 how, sp3d how, sp3d2 how. Then what are the key points of hybrid, then shapes of molecule, how we will relate. Okay, so till then watch this video and carefully. Thanks for watching this video also, and till my next video, please stay home, stay safe and take care of yourself. Okay, thank you.